Today I'm showing you how to export Grasshopper animations into D5 and Twinmotion using a simple plugin. This is really useful if you want to render things like kinetic facade animations, simulations, responsive systems, parametric openings, and more. I'll walk you through a few examples including sun-responsive facades, mesh relaxations, and attractor effects, and show you how they look in D5 and Twinmotion. Let's start. First, I'll show you how to install it. I'll put the download link for both the free and full versions in the description. Once you download, you'll get these two files, along with some example files you can practice on. To install, just select the Grasshopper script and drag it into the Grasshopper canvas. Then hit the toggle button to run the installation. Once it says installation completed, you'll need to restart Rhino. So I'll close Rhino and open it back up now. And when you open Grasshopper again, you'll see a new tab here called Exporter. You can see here it comes with two components, D5 Exporter and Twinmotion Exporter. Just make sure there are no red warnings showing. If it's clear, you're good. Now let me show you how to animate something simple. I've got this mesh box here. It moves up and down when I move this slider. Let's say we want to export that into D5. I'll drop the D5 exporter onto the canvas and connect the output to panel so we can see what it's asking for. Right now it says no mesh input detected, so it needs a mesh. I'll connect the mesh I want to export. Next, it's asking which slider to animate. I'll select this slider, press Ctrl+G to group it, and name the group Animate, so it knows what to animate. I will reconnect the wire to refresh it, and now it shows Run button must be turned on. So I'll grab a Boolean toggle, set it to true, and that's all you need. It processes the mesh, records every move, and exports everything to a folder on your desktop called Baked Animation. I'll open D5 and create a new scene, then head over to Import. On the desktop, you'll see the Baked Animation folder, open that up, and grab the Alembic file inside. Drop it directly into the scene. For some reason, the scale seems a bit small here, so to match the units, I'll just add 2 zeros to one of the axes. Now you can clearly see the same animation we created in Grasshopper. Here, you have additional controls. You can adjust the animation speed to make it faster or slower, reverse its direction, or set it to loop. You can also specify the frame range, for example, if you only want frames 27 to 48. Next, let's export the same animation for Twinmotion. I'll start by disabling the D5 exporter to prevent any conflicts. Then connect the mesh, panel, and result to the Twinmotion exporter. Run it, and it saves to the same baked animation folder, but this time as a GLB file. Now let's see how we can import it into Twinmotion. I'll clear everything to keep things tidy. Then go to Import, click the plus icon, select Animation, and navigate to the export path. Pick the GLB file from the Baked Animation folder on your desktop and import it. The only difference here is the format GLB instead of Alembic, and it might take a little longer to load if the mesh is too dense. Alright, let me show you another example, something like a facade animation you might want to try, like a sun animation or something similar. I'll load up one of the example files that comes with the plugin, so you don't have to save or set anything up yourself, just focus on the logic. This example shows a sun-responsive facade. It's set up with a curve attractor. As you move the curve here, it reacts kind of like a sun tracking panel system. Now, using the slider, we have control over the position of the effect. And this is the one we want to animate. So it's already grouped and named as Animate. Now, let me enable this exporter setup. Same process here. It goes through each frame, captures it, and exports. I'll speed this part up. It's part. Then, same as before, open D5, go to Import, find the file you just exported from the desktop, and drop it into the scene. Same scaling trick, just add 2 zeros at the end of one of the axes to match the units. Now you can see the animation transferred here. This can be integrated into your D5 animation. Maybe you can sync it with the environment or people, like it is affected by a person moving across. Alright, the next example is a pufferfish style animation, kind of like what you'd see in twinning meshes. I'll show you what I mean. Here we have a driven by a point attractor. So the main logic here is this component, twin mesh. This component works with two meshes that have the same topology, the first mesh and the second one. Based on this parameter, it blends between those two states, open or closed, kind of like a shape key, but it doesn't actually change the mesh topology. This whole setup is based on that. The attractor controls each cell's open or closing stage, and this slider controls the attractor. When you move it, the effect follows. Now let's export it and see how it looks in D5. Same idea, I'll run the exporter and import it into D5. And here's what it looks like in D5. This is just an example. You can use it for different types of morphing animations, maybe a design that opens and contracts. The idea isn't limited, so you can test different things as long as the topology stays the same. Alright, next up we've got a kangaroo mesh relaxation example. This one's really simple. I use the step solver here, and you just animate it by moving this slider. Basically, every time this slider changes, it goes over to the next iteration. So we can use this for our animation. So I grouped the slider and named it animate. Then I just ran the exporter and it created the animation. Same idea in D5. Import the latest file, drop it into the seam, and scale it up by adding 2 zeros. There it is. You can use this to show your tensile structure or some kind of simulation. Now here's something to keep in mind. Not all kangaroo components use sliders like the step solver. For example, the regular solver and the bouncy solver don't have sliders you can animate. So let me show you how to handle and export those kinds of animations. In this example file, we've got a cloth animation. It runs by itself, there aren't any sliders controlling it. So here's what I do. I take the mesh output and pass it through a component that operates at the mesh level. You could use something like combine and clean to let us capture the mesh. If you directly pass this to record data, for some reason it won't capture all iterations. So on using Catmull-Clark, it gives additional resolution and also lets us record it properly using this data recorder component. It will capture all stages of the simulation. Now, here to cycle through the recorded meshes, we use list item, and by changing the index, we can iterate through each frame. From here, we export it just like before. I'll set it to 200 frames. So that's the mesh we're exporting. I'll connect a panel just to check it says we need animate. So I'll rename the group to animate and run it. It goes through each mesh iteration, animates it, and exports. One important thing to remember here. Every mesh you export has to have the same topology. If the vertex count changes between frames, it won't work. Same idea as before. Import the file in D5, drop it into the seam, scale it up, and there's your animation. From here, everything else is pretty much the same. You can experiment and create all sorts of effects. Here's another example, a tower with a sine wave effect flowing from base to top. You can even add attractor effects to it, as long as the mesh topology stays the same. That's it for this video. I've listed the requirements and limitations in the description below. You can try it out for free, and if you'd like to support the development and unlock the full version, there's a 50% discount for this week only. Thanks for watching, and I will see you in the next one.